Hello, welcome to our channel for probability and statistics. In this video, we will talk about probability distribution of a function with a not one-to-one transformation of continuous variables. So we say if we want to find the probability distribution of the random variable y is a function of x, and x is a continuous random variable, and the transformation is not one-to-one. So this means to each value x, there corresponds exactly one value y, but to each y value, there corresponds more than one x value. So we look at an example. If x is positive over the interval -1 to 2 and 0 elsewhere, so we consider transformation function y equals x squared. So in this case, x equals plus and minus square root of y, right? Because y is square of x, so x is square root of y. But because x in this region, so we have to plus and minus for 0 and 1, and x is square root of y for the range between 1 and 4, right? So for the interval y between 1 and 4, the probability distribution of y is found as a one-to-one transformation. That is, gy, distribution of y, is distribution of, here fx is the distribution of x function formation, but we put the inverse of x with y here. Then we have to multiply J matrix. J matrix is the partial derivative of x in terms of y. So the final result is the F probability distribution of x, but with the value of square root of y, then divided by 2 times square root of y for the region between 1 and 4. But for the region 0 and 1, y, we may partition the interval x between -1 and 1 to obtain two inverse functions. So for x between -1 to 0, x equals minus square root of y. And for x value between 0 and 1, x equals positive square root of y. So if we look at this figure, it will be more clear. This is y equals x squared, because x range between -1, for example, -1 to 4. So for the -1 to 1, this area, there are two inverse functions, right? X in terms of y. So for the probability of y, we can write probability y between a and b. We have to write two x probabilities, because 0 and 1 here, for example, for the y, there are two x range, and these two x range have different inverse function. So which means has different probability. We have add plus minus here. So for the y range here, probability, there are two fx probability, right? So minus square root of b to minus square root a, this is this range. And for the square root a to square root b, this range, right? So if we change the variable of integration from x to y, we can obtain probability y between a and b. The final result is minus a and b integral for probability distribution of x, but we write minus the square root of y. Then times J1. J1 is the Jacobian matrix. This is the derivative of x in terms of with respect to y. And similarly, here is positive a to b. Then is a similar term here. So this is Jacobian matrix results. So finally, we can write for a and b equals f minus square root of y times j1 and f square root of y times j2, and gy for the range 0 between 0 and 1. The result is look like this, because this is a two part of the probability distribution of x times Jacobian. But here x, we just write the inverse of x in terms of y. And Jacobian is the derivative of x with respect to y. So for this specific problem, the final result for the y between 0 and 4 is 0 and 1 is two parts together, and 1 to 4 is only one part. Because 1 to 4, for the y between 1 to 4 in this problem, it is 1 to 1 transformation between x and y. But for value y between 0 and 1, it is not a 1 to 1 transformation, because there are two inverse functions of x in terms of y for this range of y. So that's why there are two parts addition together. Thanks for watching.